The next concept is close-packed structures. The next concept, after knowing the nearest neighbor distance and radius and edge length A relation, the next one is close-packed structure. Close-packed structure. Now observe what is meant by close-packed structure is in solid crystals. In solid crystals, the particles are spherical in shape, and these particles are closely attracted each other by a force of intermolecular attraction. By the force of intermolecular attraction, these solid spheres or atoms or particles is closely attracted to each other are linked to one another, and these particles in three-dimensional structure present in a cubes. To understand that, we are studying from one-dimensional closed packed to three-dimensional closed packed. So ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ, ಇಲ್ಲಿ ಏನು ಹೇಳ್ತೀವಿ ಅಂದ್ರೆ ಈ particles, atoms or particles are closely bounded to each other with a force of intermolecular attraction. Intermolecular attraction ಅನ್ನೋ ಫೋರ್ಸ್ ನಿಂದ ಪಾರ್ಟಿಕಲ್ಸ್ ಅನ್ನೋದು ತುಂಬಾ ಕ್ಲೋಸ್ ಆಗಿ ಒಂದಕ್ಕೊಂದು ಅಟ್ರಾಕ್ಟ್ ಆಗಿರುತ್ತೆ. ಅದೇ ರೀತಿ ಈ ಪಾರ್ಟಿಕಲ್ಸ್ ಅನ್ನೋದು ಒಂದು ಕ್ಯೂಬ್ ಅಲ್ಲಿ 3D ಶೇಪ್ ಅಲ್ಲಿ ಇರುತ್ತೆ. 3D ಮೀನ್ಸ್ ತ್ರೀ ಡೈಮೆನ್ಷನಲ್ ಶೇಪ್ ಅಲ್ಲಿ ಇರುತ್ತೆ. ಯಾಕೆ 3 ಡೈಮೆನ್ಷನ್ ಅಂದ್ರೆ ಒಂದು ಕ್ಯೂಬ್ ತಗೊಂತಾ ಇದೀವಿ. ಇನ್ ಎ ಕ್ಯೂಬ್ ದೀಸ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಆರ್ ಅರೇಂಜ್ಡ್ ಇನ್ ಎ 3 dimensional structure. To understand that, we are moving by studying from one-dimensional to three-dimensional. To study that concept we call as closed-packed structure. Just remember, the particles are held together by a strong intermolecular force of attraction, and these are arranged in three-dimensional structure or three-dimensionally. Now, the first one, closed packed in one dimension. That is closed packed in one dimension. Closed packed arrangement in one dimension or in one dimension. Close packed in one dimension. Now, to understand close packed in one dimension or in this arrangement or in this dimension, the particles are spheres. Why we call particles as spheres? Because the particles are in spherical in shape. So that where the particles is assumed as spheres, these spheres are arranged or attracted to each other, and they are arranged in a row shape. So in this arrangement, the particles as spheres are arranged in a row fashion. And those two are attracted together by a strong intermolecular force, and each particle is surrounded or held by two particles. Hence the coordination number is 2. Now observe, by writing the diagram or arrangement of particles, let you know. So observe, in this one-dimensional closed packing, the particles as spheres are arranged in a row fashion. So let us assume this is a particle, that is the sphere shape, and which is interlinked or connected to one more particle, and this particle also connected to the third particle or one more particle, and like that they are connected to each other and form a row shape, or they are arranged in a row fashion. Each are arranged like the particles. This is called one dimension. In one dimension, the particles are arranged like that is connected to each other with a strong intermolecular force and arranged in a row fashion. So observe here, each particle means one particle is connected to or attracted by the two more particles. 8 particles there, 2 particles, not 2 more, 2 particles. Therefore, the coordination number is 2 in close packing one dimension. In close packing one dimension, the coordination number is 2. This is the close packing arrangement in one dimension. Similarly, now let me have to go into study close packing in two dimension. That is close packing in two dimension. Then second one, close packing in two dimension. Close packing in two dimension. In close packing two dimension, the particles are arranged in two ways. Those two will be studied separately under close packing two dimension. In close packing two dimension alli enaguttandre ee particles annodu means these spheres are arranged in two different manner alli arrange agirutte avi how tara anta we are studying by two ways. There is two methods of arrangement of these particles. ఏ ರೀತಿ ಅರೇಂಜ್ ಆಗಿರುತ್ತೆ particles ಅನ್ನೋದು ಯಾವ ರೀತಿ ಅಂತ ನಾವು ಇಲ್ಲಿ ಕ್ಲೋಸ್ ಪ್ಯಾಕಿಂಗ್ ಟು ಡೈಮೆನ್ಷನ್ ಅಲ್ಲಿ ಓದ್ತೀವಿ. ನಾವು ಇನ್ ಫಸ್ಟ್ ಮ್ಯಾನರ್ in case 1 the particles of second row, like assume this is first row A, in two dimensional close packing in two dimension, the second row is exactly placed over the previous row. It means first row. Then you get a structure like that. Now observe, this is the first row, means previous row. This is the previous row, and the second row is exactly placed over the spheres of first row. ಈ ಫಸ್ಟ್ ರೋ ಇರುವಂತ ಸ್ಪಿಯರ್ಸ್ ಮೇಲೆ ಸೆಕೆಂಡ್ ರೋ ಅನ್ನೋದು ಪ್ಲೇಸ್ ಆಗುತ್ತೆ, ಬಂದು ಕೂತ್ಕೊಳ್ಳುತ್ತೆ. ಸೊ ಅಬ್ಸರ್ವ್, ದಿಸ್ ಇಸ್ ದಿ ಸೆಕೆಂಡ್ ರೋ which is placed over the spheres of first row. You get a arrangement like that. Now observe the first row, like assume A, this is the identical to the second row is same as that of the first row, therefore it is also called as row A. And similarly the third row is also placed exactly over the second row like that. And there is so many rows which are placed one above the another, and all are identical, so that you get a finally the arrangement of the type A like so on. It means the same rows are placed one above the another. Now you get a pattern or arrangement is like this. ಈ ತರ arrangement ಬಂದಿರುತ್ತೆ. Now observe here, each sphere is surrounded by four identical spheres. Each sphere, like assume this is the sphere. This sphere. Like take this sphere. This sphere is surrounded by four identical spheres, or same spheres. Four spheres. Therefore, the coordination number in this second close packing two dimension in case 1 is 4. And observe, in this fashion or in this manner, the particles are in the form of square. These particles are placed in the form of square. Hence it is called square close packing in two dimension. This is in the form of square. Hence this is called square close packing in two dimension. This is called what? Square close packing in two dimension. This is called what? Square close packing in two dimension. So I hope you understand, students. This fashion is called what? Square close packing in two dimension. Why it called square close packing? After arrangement of these spheres, you get a sphere like this. It means the particles are arranged in the form of square. Particles ಅನ್ನೋದು ಸ್ಕ್ವೇರ್ ಆಗಿ ಅರೇಂಜ್ ಆಗಿರುತ್ತೆ, ಒಂದರ ಮೇಲೆ ಒಂದು ಲೇಯರ್ ಅನ್ನೋದು ಕೂತ್ಕೊಂಡ ಮೇಲೆ, therefore we call square closed packing. ಅರ್ಥ ಆಯ್ತಲ್ವಾ? So this is the closed packing in two dimensional. Now the second way of arrangement of this closed packing in two dimensional that we have to discuss. Now observe in second way. So in case 2, the second layer is, or the second row is, place the depression regions of the previous layer. In case 2, the second layer or second row of spheres is placed depression regions of the first layer or previous layer. Now observe, this is the previous layer, it means first layer, that is first row. Let us assume this is the first row, that is row A, and the second row is placed depression regions of the previous row. So observe, this is the depression regions of the previous row. These are the depression regions of the previous row. So ಇದಕ್ಕೆ bend ಇದೆಯಲ್ಲ, bend shape, ಇವು ಏನಂತ ಕರಿತೀವಿ ಅಂದ್ರೆ depression regions ಅಂತ ಕರಿತೀವಿ. In this depression regions, the second row is placed. Second row ಅನ್ನೋದು ಈ depression regions ಅಲ್ಲಿ place ಆಗುತ್ತೆ. Like it is placed over the depression regions of the second row. So previous row, place over the depression regions of the previous row. Similarly observe, here also place like. These are placed like depression regions of the first layer, that is previous layer. Now observe, in this case, each atom or each sphere is surrounded by 6 spherical atoms. Each sphere is surrounded by 6 spheres, that is 6 spheres. After joining the centers of the 6 spheres, you get a hexagonal shape. Hence we call hexagonal closed packing in two dimensional. This is square closed packing in two dimensional, but this is hexagonal closed packing in two dimensional. When you get hexagonal closed packing in two dimensional, when the second row of the spheres is placed depression regions of the first layer or first row, then only you get hexagonal closed packing in two dimensional. And here the coordination number is 6 because each particle is surrounded by 6 particles. This is the second way of arrangement in closed packing two dimensional. This is first way and this is the second way. Now in the second way of closed packing, we can see two types of the triangles. Here observe, there is a two types of triangles. This one, let's take this triangle. This is like top, the corner is shown above side, means top face, and this one is below the face. So observe, I will write here, if two spheres is like that, one sphere and the second sphere, then third sphere. If these two are joined like 1 and 2. So observe, here you get two types of triangles. This is one type of triangle, this one. This is one type of triangle and this is second type of triangle. And this is the first type of triangle. Two types of triangles we are seeing here. In these two cases, the triangles are, the sharp edges shows upside, and in this case the sharp edge is shown downside, and but in this case means in two dimensional close packing you can see only one type of square, like all are same as it is, means all are identical, but in hexagonal close packing you can see two types of triangles. One is above, means the head is showing above side, top side, and one that is below side, downside. Therefore the hexagonal closed packing is more efficient than this square closed packing in two dimensional. So remember, in hexagonal closed packing there are two types of triangles. One type is shows top side and another type is shown are seen downside. But in square closed packing, all these voids, this is called voids, this empty space is called voids, are called empty space. ಈ ಖಾಲಿ ಇರುವಂತ ಜಾಗನ ಏನಂತ ಕರೀತೀವಿ ಅಂದ್ರೆ ಎಂಪ್ಟಿ ಸ್ಪೇಸ್, ಅಂದ್ರೆ ಖಾಲಿ ಜಾಗ ಅಂತ ಕರೀತೀವಿ. ಇಲ್ಲ ಅಂದ್ರೆ ವಾಯ್ಡ್ಸ್ ಅಂತ ಕರೀತೀವಿ. ವಾಯ್ಡ್ಸ್ ಅಂದ್ರೆ ಹೋಲ್ಸ್ ಅಂತ voids ಅಂತ ಕರೀತೀವಿ, ಇಲ್ಲ ಅಂದ್ರೆ ಎಂಪ್ಟಿ ಸ್ಪೇಸ್ ಅಂತ ಕರೀತೀವಿ. In two dimensional square closed packing there is large empty space, that is voids, that is like a tetrahedron, that is like a square. And in hexagonal this is like a square triangles. There are two types, one is shows top side and one more is shows downside. Therefore the hexagonal closed packing is more efficient than two dimensional square closed packing. So this is called what? Hexagonal closed packing in two dimension. Hexagonal closed packing in two dimensional. This is called hexagonal closed packing. Now, so I hope you understand what is meant by closed packing in two dimension and what are the types. There are two types. One is square closed packing and second one is hexagonal closed packing. Now you know one dimension represent one dimension closed packing and two dimension closed packing. Now we are going to study three dimensional closed packing. So one dimension ಮತ್ತೆ two dimensional ಅರ್ಥ ಆಯಿತು. ಇವಾಗ three dimensional ಅನ್ನ ಈಸಿಯಾಗಿ ಅರ್ಥ ಮಾಡ್ಕೋಬಹುದು. Now three dimensional closed packing. Then next one, that is closed packing structure in three dimension. After knowing first and second closed packing dimensions, we are going to study closed packing structure in three dimensional. In this closed packing three dimension there is many methods or many types of crystal units. Now the first one is conversion of two dimensional, that is square two dimensional conversion of two dimension square closed packing into three dimension. There are many methods to convert, or there are many crystal of three dimensional closed packing. Now we are going to study the first one, conversion of two dimension square closed packing into three dimension closed packing. In this case the sphere of second layer is placed exactly over the layer of two dimensional square closed packing. ಅಂದ್ರೆ ಇಲ್ಲಿ ಏನು ಹೇಳ್ತೀವಿ ಅಂದ್ರೆ ಸೆಕೆಂಡ್ ಲೇಯರ್ ನ ಟೂ ಡೈಮೆನ್ಷನಲ್ ಕ್ಲೋಸ್ ಪ್ಯಾಕಿಂಗ್ ಅನ್ನೋ ಲೇಯರ್ ಆಲ್ರೆಡಿ ಒಂದು ಇರುವಂತ ಸೆಕೆಂಡ್ ಕ್ಲೋಸ್ ಪ್ಯಾಕಿಂಗ್ ಲೇಯರ್ ಮೇಲೆ ಎಕ್ಸಾಕ್ಟ್ ಆಗಿ ಪ್ಲೇಸ್ ಮಾಡಬೇಕು. ಲೆಟ್ ಅಸ್ಯೂಮ್ ದಿಸ್ ಈಸ್ ದಿ previous square closed packing layer. Previous means first square closed packing layer, and the second square closed packing is placed exactly. You get a square closed packing in three dimension. This is the arrangement you can see in simple cubic crystal lattice. Now observe, this is the square closed packing first layer. This is the square closed packing first layer. So observe, you know already square close packing in two dimensional. This is the square close packing in two dimensional. Square close packing in two dimensional. In this case, let us assume this is the layer A because all are identical. So let us assume this is the layer A. In this layer A, the second layer is exactly placed over this layer. Second layer ಅನ್ನೋದು ಇದರ ಮೇಲೆ ಬಂದು ಕೂಡಿಸಬೇಕು. So exactly ಬಂದು ಇದರ ಮೇಲೆ ಕೂಡಿಸ್ತಾ ಇದೀವಿ. So that is represented like, means that is written like on board. Observe, this is the second layer I placed exactly over this first layer. So this is the second layer exactly I am placing, not on depression regions. ಎಲ್ಲ ಸೇರಿಸ್ತಾ ಇರೋದು ಎಕ್ಸಾಕ್ಟ್ ಇದ್ರ ಮೇಲೆನೆ ಪ್ಲೇಸ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ, ಒಂದ್ರ ಮೇಲೆ ಒಂದು. ಅಂದ್ರೆ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ದಿಸ್ ಇಸ್ ದಿ ಸ್ಪಿಯರ್ ಆಫ್ ಫಸ್ಟ್ ಲೇಯರ್, ದಿ ಸೆಕೆಂಡ್ ಸ್ಪಿಯರ್ ಇಸ್ ಆಲ್ಸೋ ಪ್ಲೇಸ್ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಓವರ್ ದಿಸ್ ಒನ್. ಇದ್ರ ಮೇಲೆನೆ ಕೂರಿಸ್ತಾ ಇದ್ದೀವಿ ಇನ್ನೊಂದು ಸ್ಪಿಯರ್ ಅನ್ನೋದು. ಸೊ ಎರಡು ಒಂದ್ರ ಮೇಲೆ ಒಂದು ಕೂರಿಸಿದಾಗ ಏನಾಗುತ್ತೆ, ಎರಡು ಒಂದ್ರ ಮೇಲೆ ಒಂದು ಇರುತ್ತೆ, 3 dimensional. Now observe, this is like a square. Means like that. ಒಂದು ಸಿಂಪಲ್ ಕ್ಯೂಬಿಕ್ ಲ್ಯಾಟಿಸ್ ಅನ್ನು ತಗೊಂಡಾಗ ಇದೇನಾಯ್ತು, ಇನ್ಸೈಡ್ ಇರುತ್ತೆ like that. So now simple cubic lattice it is, and each corners there is a one particles. ಪ್ರತಿಯೊಂದು corners ಅಲ್ಲಿ ಏನಿದೆ ಒಂದೊಂದು particle ಇದೆ. So this is the arrangement you can see in simple cubic crystal lattice. Means such type of arrangement is observed in simple cubic crystal lattice are called primitive cubic crystal lattice. This is the one type of arrangement, that is conversion of two-dimensional square close packing into three-dimensional square close packing, and this is overall called as A, so on, this types of arrangement. ಅಂದ್ರೆ ಈ one layer ಅನ್ನ A ಅಂತ ತಗೊಂಡ್ರೆ, ಅಂದ್ರೆ white chalk piece ಅಲ್ಲಿ ಒಂದು layer 1 ಅಂತ ತಗೊಂಡ್ರೆ, this colored chalk piece, blue color chalk piece is assumed as layer 2, and both are identical, therefore A, and the third layer is placed away from this one, that is also identical, like that. That is overall present in the crystalline lattice. Just we are taking simple cubic crystalline itself, in there the particles is like that. This is called conversion of two-dimensional square close packing into three-dimensional square close packing. Now the next one is conversion of two-dimensional hexagonal close packing into three-dimensional. Conversion of two-dimensional hexagonal close packing into three-dimensional. So observe, in next case, that is second case, to convert, that is conversion of two-dimensional hexagonal close packing into three-dimensional. You know, this is called two-dimensional hexagonal close packing. So already you know two-dimensional hexagonal close packing. This is the two-dimensional hexagonal close packing. Now this two-dimensional is converted into three-dimensional hexagonal close packing. And I told you in two-dimensional hexagonal close packing, you can see two types of triangles. So observe, this is one type of triangle that is showing above direction. The sharp edge is showing above direction, and this is below direction. So you can see clearly two types of triangles, and you know arrangement, that is the layer 1 or the row 1 is placed exactly the depression regions of the layer 2. So let's take this is layer 1A. If you take layer 1A or the row 1, and this is row 2, means B, because why we call B? In this case the rows are placed the depression regions of the row 1, therefore these two are not identical. Ivedu identical alla, yakendre row 2 ಅನ್ನೋದು row 1 depression region ಅಲ್ಲಿ ಕೂತ್ಕೊಂಡಿದೆ. ಆದ್ರೆ one dimensional ಏನಾಯ್ತು, row 2 ಅನ್ನೋದು row 1 ನ ಕರೆಕ್ಟ್ ಆಗಿ ಅದು ಸರ್ಕಲ್ ಮೇಲೆನೇ ಕೂತ್ಕೊಂತು, ಹೆಡ್ ಮೇಲೆನೇ ಕೂತ್ಕೊಂತು. therefore that is called one dimensional. This is two dimensional. Now this is the two-dimensional hexagonal closed packing. Now it is converted into three-dimensional. In this conversion of three-dimensional, the second layer of hexagonal closed packing. The second layer of this is like as layer 1. This is layer 1. Layer 1. This layer 1 and layer 2 take second layer of hexagonal closed packing. That is exactly placed over the first layer of hexagonal closed packing. So hexagonal closed packing na ee layers mere andre on this depression regions mere place ಮಾಡಬೇಕು. So ಇದು depression region, ಈ depression region ಮೇಲೆ second hexagonal closed packing structure ಅನ್ನು place ಮಾಡ್ತಾ ಇದ್ದೀವಿ. So observe ಮಾಡಿ second place ಮಾಡ್ತಾ ಇದ್ದೀನಿ, writing in color chalk please. So this is the second layer of hexagonal closed packing. One layer, and similarly observe second layer. And here also. Like that, second layer, and similarly right here one more. Like that. So observe, it is a bit difficult to write, but now observe here, and similarly get here one more layer like that. So ಈ ರೀತಿ ಬರ್ತಾ ಇರುತ್ತೆ spheres ಅನ್ನೋದು. This is second dimension representation. Now observe, this can be simply written like here I take one portion I take a portion that can be simply written like here we can see two types of nodes ಅಂತ ಅದು ವೈಡ್ಸ್ ಅನ್ನು ನೋಡಬಹುದು. We can see two types of wides in this hexagonal three dimensional closed packing. We can see two types of nodes. Now observe, in this case the first node, if you take, this is the layer 1. So you layer 1 A anta tagondaga, layer 2 is exactly placed over the depression regions of layer 1. Layer 2 anta tagondidri, layer 1 ಆಯ್ತು, layer 2 ಅನ್ನೋದು ಏನಾಯ್ತು exactly ಈ depression regions ಮೇಲೆ place ಆಯ್ತು. ಕೂತ್ಕೊಂಡಾಗ ಏನಾಯ್ತು ಅಬ್ಸರ್ವ್ ಮಾಡಿರಿ, get a, this is layer 2, this is layer 1, and you get a node here, one node. This node we call tetrahedral wide ಅಂತ ಕರೀತೀವಿ. This node, and this is called wide. This wide is called tetrahedral wide. This wide is called tetrahedral wide. Why we call tetrahedral wide? Observe, let's take, this is the point of the circle, center point of the circle. These are the three center point of the circle, and this is center point of this fourth circle. Now this is right here 1 2 3 circles, and join these three, that is the layer 1, first layer, and this is between these 3 points. So right here, that is second layer, and join these 3. So you get a shape of tetrahedral. Hence we call this wide is tetrahedral wide. Similarly, to know octahedral wide in three-dimensional closed packing, observe, this is the three-dimensional closed packing. 1 2 3 spheres, and this is the layer 1. The second layer is exactly placed depression regions of the previous layer, this first layer. Now observe here, right, two layers. This is one, second layer, and this is third sphere, second sphere, third sphere. Now observe, here you get a sphere like that means ಇಲ್ಲಿ ನಿಮಗೆ ಒಂದು ವೈಡ್ ಬಂದಿರುತ್ತೆ. ಆ ವೈಡ್ ಯಾವ ತರ ಇದೆ ಅಂದ್ರೆ ಈ ತರ ಇರುತ್ತೆ. ಈ ತರ ಇತ್ತು, ಮೇಲೆ ತೋರಿಸ್ತಾ ಇತ್ತು ಫೇಸ್ ಒಂದು ಟ್ರಯಾಂಗಲ್ ಮೇಲೆ, ಇನ್ನೊಂದು ಏನಾಯ್ತು ಕೆಳಗಡೆ ತೋರಿಸ್ತಾ ಇತ್ತು. ಸೊ you get a wide like this here. ಇಲ್ಲಿ ಈ ತರ wide ಅನ್ನೋದು ಬಂದಿರುತ್ತೆ. This wide is called octahedral wide. This is called octahedral wide. Octahedral wide. This is called octahedral wide. Why it called octahedral wide? ಯಾಕೆ octahedral wide ಅಂತ ಕರಿತೀವಿ ಅಂದ್ರೆ, ಇಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿ ಏನಾಯ್ತು ಅಂದ್ರೆ, ಫಸ್ಟ್ ಅಲ್ಲಿ 3 circles ಬರ್ತೀವಿ, 3 circles. Those 3 circles is I am writing here. The first 3 circles are 1, 2, 3. 3 circles. These 3. Layer 1. And similarly, layer 2 circles. Join these 3. Join these 3. And layer 2. ಮತ್ತೆ ಮೇಲೆ ಬರ್ತಿದ್ದೀವಲ್ಲ ಆ layer ನೋಡಿ 3 circles. 1, 2, 3. 3 ಆಯ್ತು. ಯಾಕೆಂದ್ರೆ ಮೇಲೆ ಏನು ಬರ್ತೀವಿ, ಕೆಳಗಡೆ ಒಂದು ಬರ್ತೀವಿ. ಫಸ್ಟ್ ಅಲ್ಲಿ ಏನಾಯ್ತು, ಉಲ್ಟಾ ಬರ್ತಿದ್ದೆ. ಸೊ ಅಬ್ಸರ್ವ್ ಮಾಡ್ತಾ ಇರಬೇಕು, ಅರ್ಥ ಆಗಿಲ್ಲ ಅಂದ್ರೆ ರಿಪೀಟ್ ಮಾಡಿ ನೋಡ್ತಾ ಇರಿ. ಸೊ ಈ ತರ ಆಯ್ತು. ಸೊ ಜಾಯಿನ್ ದೀಸ್ 2. ನೌ ಜಾಯಿನ್ ದೀಸ್ 2 like, and join these 2 to this one in a dotted line. Just to understand, we are writing dotted lines. Dotted lines, that is away from us, and this is towards us. So join like now from here to there. ಈ ತರ ಬರಲಿ. Now this is an octahedral geometry. ನೋಡಿ ಎಷ್ಟು ತರ ಟ್ರಯಾಂಗಲ್ ಫೇಸಸ್ ಕಾಣಿಸ್ತಿದೆ. 1 ಟ್ರಯಾಂಗಲ್, 2, 3, 4. ಈ ಕಡೆಯಿಂದ 4 ಆಯ್ತು. ಅದೇ ರೀತಿ ನೋಡಿ ಇದು 1, 2